So what is digital manufacturing? I'm Olly and welcome back to the FACIT Homes channel, and today we're going to talk about digital manufacturing and what this term really means. So digital manufacturing is a core part of our pioneering approach and how we design and build high-performing homes. And we're one of the world's first home manufacturers to use a purely digital design to production process. But as a company operating in this niche overlap between the design, architecture, manufacturing, and construction industry, what does this term really mean? So what does it mean for something to be digitally manufactured? This is also sometimes referred to as digital fabrication, but digital manufacturing is a design and manufacturing workflow where digital data drives the manufacturing process. So essentially starting a design on a computer and ending with a precisely produced physical product. Digital manufacturing has a couple main advantages. One, it ensures accuracy and precision. And two, it offers exciting new design opportunities for designers and architects. And this is where you can go directly from file to fabrication. Almost like you do when you print something. You hit print on your computer and you convert it into a physical piece of paper, essentially, or 3D printing of products that you've modeled in a 3D software. The end-to-end digitization of manufacturing for construction removes things like human error. So traditional methods would see a builder essentially making a building by hand on site and potentially interpreting your drawings or design incorrectly or inconsistently. So using our advanced design for manufacturing assembly process, we design and fabricate unique structural components, shapes that would not be possible to produce by hand, and then we fabricate them directly using our on-site manufacturing. And this is also in contrast to traditional prefab, where they have production lines that often replicate manual processes at scale, just simply in a factory. So we are seeing digital manufacturing transforming designers into makers. And digital manufacturing has become hugely influential in the architecture industry, and it's blurring this line between designing and making, and has led to this transition in the AEC space, the architecture, engineering, and construction, where companies that would have been traditionally designing only now also making. Digital manufacturing is often associated with the machine that actually manufactures, so the actual 3D printer or the robotic arm, but it actually describes a complete end-to-end digital process. And this is now enabling architects and designers to get back to being master builders. So back in the day, the architect was the designer, but also the builder, and referred to as a master builder, and that's actually where the name architect comes from. Archi meaning chief, and tekton, which is builder. Now with the rise of digital fabrication methods such as CNC cut timber or 3D printing concrete and robotics, we now see architects being able to reconnect with the act of making, and here at FACIT we're a prime example of that. Through digital manufacturing, we design, manufacture and build our homes. We are your architect, but we're also your manufacturer and builder, which comes with a host of benefits. So how does our FACIT system work? So the way that we build starts in the studio with a 3D model of our FACIT home, and our architects have designed this to suit your customer needs and your site. We create this in BIM software, and this model contains a huge amount of detailed information so we can go from design to manufacture, particularly for our advanced timber structure, the FACIT chassis. All of the underlying chassis models can be separated into individual parts to isolate the details of each structural component. Once we have them isolated, we can deconstruct each component into its flat patterns and convert this into what's called G-code, a computer language that can be used to convey instructions to the automated machinery. The production information is gathered and G-code is sent to our CNC router, which is a computer-controlled cutting machine with a spinning blade that cuts patterns out of flat sheets of FCS spruce plywood. Timber is perfect for this kind of production and construction process like ours because it's a material that can be used with a CNC router and is strong, durable, and most importantly, sustainably sourced. Once cut, the plywood flat patterns are then assembled into 3D components. These look like big Lego boxes essentially. They are assembled to create the FACIT chassis. And this concept extends beyond just the timber structure of the home to encompass the entire construction process in itself, and also specific features within the home. For example, we have successfully designed and manufactured unique laser cut steel staircases, tree columns, and intricate facade elements showing the diverse opportunities and processes that digital manufacturing gives us. So we can essentially utilize different materials and machinery for digital manufacturing different parts of the building. Precise information from this model is also used to supply accurate production data to our partner manufacturers, such as our triple glaze window manufacturer, Velfac. And this ensures that every window is exactly made to the right size based on a schedule exported directly from our 3D model. There are also other types of digital manufacturing. In many ways, the process is more important than the type of manufacturing that you use, really. However, because we often identify digital manufacturing by the machinery itself, like the 3D printer, we think it's important to kind of outline what are the main types of digital fabrication or digital manufacturing they are. And we can kind of break these down into three main categories: subtractive, additive, and robotic. So starting with subtractive manufacturing refers to computer-controlled machinery processes which start with some kind of solid material that is then shaped by removing via cutting, boring, drilling, and grinding. This is the category that we fit under at FACIT Homes as we subtract material. In other words, our CNC machine cuts out material from sheets of plywood. Subtractive is more common when working with timber or metal, and the machinery can come in a range of different ways, from CNC routers, plasma cutters, water jet cutters, or even combining them with robotics. Next, we have additive manufacturing. In simple terms, this is when we add material layer by layer. The most commonly known additive approach is 3D printing. So this is when a machine prints out material like plastic, or in the AEC space, concrete, layer by layer to build something up. And this technology has for many years only been at the scale of your desktop printer. But more recently, this is scaling up now, and we're starting to see people print structures or even entire buildings using 3D printing. Finally, we also have robotic, which is a bit of a more broad category, as you can use robotics with additive and subtractive methods, but robotics can also cover other types of digital manufacturing that don't necessarily involve cutting away or directly adding material. It can be used to describe machining processes like bending or folding and weaving. So digital manufacturing is unlocking new ways of thinking. The various digital manufacturing approaches we just mentioned open up new ways of thinking for architects, designers, and engineers. Of course, here at FACIT Homes, we have pioneered a completely new approach to building sustainable homes here in the UK through digital manufacturing and our FACIT chassis system using subtractive manufacturing technology. We have further pushed this concept by pioneering the on-site microfactory approach, where we bring digital manufacturing technology to the building site. And this for us has unlocked a completely new model for delivering homes, and also enabled us to deliver highly precise, sustainable homes at lower cost and greater speeds than traditional construction. Another example in the housing space are companies like Icon and Cobod. So these companies are utilizing 3D printing, so additive manufacturing, to 3D print homes. Icon, for example, are based in Texas and have been 3D printing homes with their pioneering 3D printers called the Vulcan and some other ones. Similarly, Cobod have also developed their own 3D printing technology and put it into the hands of other contractors and designers to enable them to print their own projects. And finally, in the robotic space, there's universities like ETH Zurich and the University of Stuttgart, which are highly influential in this sphere of digital manufacturing and are constantly pushing the boundaries of what can be achieved by this technology. Recently, researchers and students from the University of Stuttgart has used robots and drones to weave this carbon fiber pavilion, which is based on the silk hammock spun by moth larvae. And researchers from ETH Zurich University have pioneered a method of robotic construction, which is being used to create computer-designed modular houses in the city. Again, illustrating ways digital manufacturing can unlock completely new ways to design and build. This, of course, brings us to the future of building homes. As the future of house building continues to be explored in different ways by individuals, companies, universities, research facilities, we're proud to be part of that ever-evolving industry, creating better solutions for outdated practices. Digital manufacturing is bringing us new solutions to the housing space to help us tackle larger issues that we face, such as the housing crisis and building sustainably. Digital manufacturing does bring with it a number of benefits. It ensures accuracy and precision and offers exciting new opportunities for architects and designers. The end-to-end digitization of manufacturing for construction reduces human error and the need for human labor, which is a big issue in house building right now. It also offers an opportunity for a system with far more accurate cost management, which again is a huge issue in home construction. And it can be used to create shapes, ideas, and designs that would not have been possible by hand. We hope to see more and more companies following this progression and exploring the opportunities that digital manufacturing allows us in the built environment. You also keep an eye out for FACIT Homes as we start to explore how we can scale our own technology and manufacturing process to deliver larger scale projects. Otherwise, thank you again for joining us. If you like this video, give us a like and subscribe so we can help grow the channel. Otherwise, we look forward to seeing you in the next video as we continue our discussion around the future of home building.